Hey everyone, just wanted to film a quick video explaining how this sheet works here, which is the load velocity profile and comparison tool. So with this sheet, really the purpose of it is simply to look at load velocity profiling separate from any sort of programming or dosing or anything else. It's just kind of, hey, here's my profile from, when I'm starting a cycle or even in the middle of a cycle. How is it changing? How is it compared with someone else's profile, and looking at some of these other metrics for the purpose of just evaluation. And there's even an opportunity here towards the end of these other tabs to store multiple lines of data if you'd like, as you track maybe multiple profiles for different exercises even throughout the course of a time. So quick videos, we just kind of explain some of the most important attributes to a sheet like this. Number one being, of course, the name to identify the athlete. The exercise, in this case, we chose a strict press or a barbell overhead press. A predicted 1 rep max, this is in pounds, and a minimum velocity threshold. So you can guess at this. You can take an educated guess by reading some literature out there that references what is typically a minimum velocity threshold with this exercise. For me, I found out that it was 0.23 meters per second, which is mean velocity. So I know that I'm going to fail if on a pretty tough effort set towards the end, or even like a 1 rep max scenario, that if I'm anywhere close to 0.23, it's probably going to be it. I just cannot complete one more rep unless it's at least this speed. Without this here, none of this linear regression works accurately, in the sense that it's not going to be able to really predict what my max is. Or if it does, if in this case it doesn't break the formula, it will just assume that you can lift this much weight at 0.0 meters per second, which is impossible. So let's move on from there. You'll need to populate the loads and corresponding velocities here. So we can kind of just delete it as we go, and you'll recognize how this works. And that if I at least have 2 data points, I can actually predict a max. So with just these 2 data points at these speeds, it's saying that my estimated 1 rep max is 176. And as I add just one more line of data, it gets more accurate, which is important. Now you're seeing that it's at 166, which is slightly higher than my known 1 rep max. So it looks like we're on track there, but that might not always be the case. But of course, it's super accurate if you decide to do one more set that's like right at your max, and notice that it's at 0.25 or 0.26. It'll get more accurate. So now it's like 163, 164. So all of these metrics here just kind of represent how everything looks based on linear regression of your lightest set to your heaviest set. And looking at, even if you were to do a set purely for the purpose of power output, then looking at my profile, I'm going to produce the most power with 99 pounds. I'm going to move it pretty fast, and I'm going to yield the highest power output score of 83. And let's say I'm moving 115, a little bit slower, so 70. That might change things. Now it's saying 98 pounds, it's saying my max is off. So you really want this profile to be pretty accurate so that these metrics are accurate. So I would recommend the 963 protocol that's shown in another sheet that I offer, but which shows 40%, 60%, and 80% as a profile, which is pretty good at really looking at 3 different types of strength. But you can really do whatever load and whatever percentage that you want. Just make sure to have the best velocity of that whole set plugged in, which I'm kind of more of an advocate now, rather than, hey, the best rep, to also the best, the average speed of that whole set. If I'm doing, in the case of the 963 protocol, what's the speed of all 9 of my reps at 40%? That tends to give a little bit more of an accurate profile at the end of the day, but you absolutely can just, hey, do a set of 5, and all right, what was my best speed? All right, cool. That's what I'm typing here next to the load, and then go from there. So yeah, some of these other graphs kind of show, again, here's my power potential. It's going to be right at 100 pounds. All right, that's where I'm going to have the greatest power output, and power output diminishes as I go higher and higher towards a weight that I can't even do. So I can't even move that much weight, so I'm definitely not going to produce much power out of that. And even the lighter weights, you'll notice, don't yield as much power until I get to at least the medium heavyweight, which is looking like it's somewhere around 60%, which makes sense. Area under the curve is a really important metric. This really looks at this entire space here underneath your load velocity profile, underneath your curve. This is another chart that kind of shows it, which can really predict athletic potential, especially for someone like a thrower. Like if you have more area under the curve, which means that you're either moving the lighter weight faster or even the heavier weight faster, or you can just move more weight, then you're going to have a lot more square footage, if you will, under this curve here, which shows just more strength reserve or strength capacity, which those are pretty popular terms here in the strength conditioning world right now. But you know, people can say that 1 rep max is always showing strength reserve. I would disagree. It's not always proving that strength reserve is there. You need some of these other metrics, such as, or other data points, such as lighter loads and their velocities, to really show strength reserve. You can't just figure all that information out just because of someone's 1 rep max, because you can really be terrible at these lower loads speed-wise and not have much to work with on the back end. So area under the curve, coined by Mladen Jovanovic, is an amazing metric for assessing really power output in total for athletes. So looking at this other tab here, you can see that it's actually based on percentage instead of load. So if you just type in the percentage, it will automatically show the load, and then you can type in the velocity there. So someone might prefer to have this format instead. So here's just some sample data that you can use. The cells that are filled with the gray color are the ones that you can edit. I do not recommend editing some of these other cells, as you could break the formulas. So the gray cells are grayed out for a reason. You want to be able to edit those. This is my favorite feature of this sheet, which is looking at 3 different athletes, or even the same person, just 3 different exercises. I've even done this with squat types. I've done like a back squat, a Hatfield squat, and a box squat, all really comparing maybe the same load, but the velocity associated with each type of squat, things like that. But where low velocity profiling gets super interesting is when you're looking at 3 different people. And what originally, I love this case. This is a real case study here, that we found out that this individual, Spencer, ended up being able to bench press way more than 275. But at the time, our 1 rep maxes were almost identical, 275. And my velocity 1 rep max, estimated, having only worked up to 78%, is saying it's 265, because I really am not great at moving these submaximal loads for speed. Whereas Leo, a little bit better, Spencer, a whole lot better. And this is the one athlete of the 3 of us that's an actual track and field thrower. He's a discus and shot state champion, and it shows with his area under the curve being so much higher than ours at 177. And if we had a football throwing contest, I guarantee you, from a yardage standpoint, it would look just like this, which is really interesting just from a bench press. Here's kind of showing our load velocity relationships, and Spencer's really trending so much higher than ours. So really cool application of load velocity profiling that revolutionizes strength assessment, in my opinion. So here's one that you can use to populate 4 different scenarios here, 4 different athletes or 4 different exercises, however you want to do it. And here's where I mentioned earlier that you can store kind of multiple data, and then if you want, just kind of copy and paste it into these other sheets if you want to analyze it again. So pretty all-encompassing tool here for load velocity profiling and comparison. I hope you guys find it useful, and I look forward to hearing how you guys use it.